This is quite daunting, so this is me trying to calm myself down or whatever. I'm going to stand here and talk in this kind of boring, old-fashioned way near the microphone so that approximately the same volume all the time, and also so that I don't run the risk of falling off the stage. Being here at this lectern reminds me, yesterday I was talking to some cattle people in Victoria, and they had a little lectern, not as fancy as this one, but that's Australia, you see. And at one point, like the slides were kind of behind, partly behind where I was standing, so people couldn't see very well, so I'm sort of leaning around like this so that they had a better view, hopefully. And I was sort of saying, you know, it's like an after-dinner speaker, sort of lean on the lectern and tell a few jokes and what have you. And afterwards, the guy that got me to come over and speak said, yeah, it was good that you didn't lean too much more because it was on wheels. And so, yeah. Look, it's very nice to be here. I have met some of you through the work of this review, and that was a really nice thing to do. It was very nice to be asked by Dan and Jason and the team to do a review of the beef and lamb genetics portfolio and think about the future a bit. I did it with Dr. Peter Fennessy. I don't think Pete's here today, but many of you will know Pete, and it was very interesting, and I think we learnt some useful things to feed back to you to think about where the industry is positioned and where it's going, and that's what I'm going to try and cover in this first session this morning. And so, just to sum up, that's what I'll do. I'll give you a bit of overview of the review that we did, and then talk particularly, as Alan said, about how we see genomics fitting into that, achieving that vision, and in particular, a couple of challenges around full utilisation of genomics, which I hope I'll explain clearly enough, but which I think are fundamental to getting the best out of a really, really powerful technology. Genomics has basically become the core of livestock and in fact plant improvement in certainly the developed world, and it's spreading everywhere else as well, and hopefully you'll get some idea of why that is if you don't already have a pretty good idea of it. But just to give you some idea of what people are getting out of using genomics now, I'm involved in some tree breeding in Australia, not actually doing it, but I'm on a sort of advisory board, and we're just switching into full implementation of genomics, and we're quite confident that we're going to get 40, 50, 60% improvement in the rate of genetic progress in that industry. For my sins, I get to eat oysters as part of an little oyster breeding operation. So the Christmas bonuses are really good. You get a big basket of oysters, it's great. But we've just switched on genomics there, and we're completely sure we're going to get 40 or 50% improvement in rate of progress. The dairy cattle worldwide is being transformed by it, so it's not something that's kind of, oh, maybe it'll work one day, or it's all hype or something like that. It's becoming just sort of seamlessly integrated into livestock and plant genetic improvement and business, basically. And so part of what I'm going to talk about is how your industry can really hook into exploiting genomics in really powerful and effective ways. So that's a little bit of background, gets my heart rate down a little bit. I'm Australian, talking to a whole bunch of New Zealanders who's in the sheep industry is a little bit of a challenge, but anyway. to start off, I'll just summarise the kind of messages that we got out of the impressions and so forth from the review. There are very, very real challenges for the New Zealand sheep industry, and I'll be touching on them. But you've got a pretty strong platform to face the future with. Alan touched on it with the achievements of the last 20, 30 years. I'll be looking at that in just a second. But you've actually done a pretty outstanding job in New Zealand in improvements in the sheep industry. It's probably fair to say that if you hadn't, none of you would be here because there wouldn't be an industry. That might sound like a geneticist's bias, and just to be very clear, I am completely biased about genetics, but seriously, you wouldn't be here if you hadn't had the improvements that have been made through genetics. And that's, as Alan said, that's been a mixture of people like the beef and lamb team, people in the ag research and universities and people like Abacus and NextGen, working together with the industry to make almost continuous improvements in the methods of evaluating animals, the genetic evaluation system, and then using them to breed better and better animals. And that capability is pretty awesome. It's not like there are millions of geneticists in New Zealand just walking around fixing things. It's been a fairly small number of people doing internationally very, very good work, and you've still got that basis. So that's encouraging. So that's the first point, is just to say that there are challenges, but you have the technology and the human capability to be confident about the future. It's not like, oh, the reason we've got an Australian to come and talk to you is because we don't want to tell you it's all going to go to shit in 5 years' time. We'll get an Australian to do it for you. You're in a good place, but Alan's graph about the exponential rise, it's kind of like the challenges are not getting smaller, so we've got to use all our abilities and so forth to tackle them. Just quickly on the review, we talked to a lot of people across the country from all sectors of the industry. It was like something like 50 or 60 interviews that we did. And in general, it's completely fair to say that people were optimistic. They were open, they were prepared to share, they were frank, etc. There was also George and Peter and Michael, but they were frank. That's a joke, by the way. I find it's quite useful to tell people when you've made a joke. So we talked to a lot of people, and it was a very productive round of conversations, and that was really encouraging. It's very clear that there's been enormous change in I'll say the external environment of the industry over the past 20 to 30 years. The really big ones that stand out are the collapse, I guess is the right word for it, of the wool price back about 20, 25 years ago or so, and also the influx of forestry, neither of which the sheep industry had really much control over. So wool price collapsed because wool price collapsed, and forestry because people thought it was a good idea to plant trees everywhere and subsidise people to do so, so that, you know, they're kind of big things that affected the sheep industry that you didn't really have much control over at all. At the same time, as you'll see in a minute, there's been huge improvement in productivity and in earnings per ewe. There's also a bit of a sense that there's the rate of what's called total factor productivity improvement has flattened off a bit in the last 10 years or so. So genetic improvement trends have been continuing in sort of the rate that they have been going for the sort of over 20 years or so. But it's not so obvious that the rate of improvement in what's actually produced and delivered has fully exploited that. And we thought a little bit about some of the reasons why that is. I'm not going to be talking about it very much, but it is something to be thought about, and I will come back to it a little bit. But genetics, it's important to realise that genetics, changing animals, making them more productive, healthier, blah, 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 it doesn't do all the work for you. And I suspect this is the case for most industries, that in fact, the further you go with genetic improvement, the more important it is to be managing the genetics really well, which in the case of sheep means making sure they've got the right feed and you're managing the feed and the animal interaction properly. And there's a kind of, it's actually a positive feedback thing. Generally speaking, people who know about genetics and get better genetics on their farm will tend to be better managers, and having good genetics means you get more out of management, and having good management means you get more out of genetics. But the two do need to go together in a ratchet, and I think it's quite an important thing for beef and lamb to think about as it's kind of a strategy thing, is to make sure that the support for how to get the best out of the genetics is as good as just how to do the genetics. So the interaction between nutrition and animal health and genetics is a really important one, and it doesn't become less important just because genetics is completely and utterly fantastic, which it is. It's important to make sure people know how to get the best out of it. It's quite clear that declining ewe numbers are a quite significant issue, or big issue. If they get too small, you start to run out of R&D funds, you start to not be able to meet market commitments and you know, deliver volumes of product and what have you. So this, hopefully the review is part of a process of really starting to change, building that confidence back into the industry and starting to grow ewe numbers back. We might come back to the profitability issue a bit later. Just to reinforce the point again, as Alan made, this is a slightly different picture but the same story overall. The two lines on this chart are the real income per ewe over time for the whole industry. The red line is meat income per ewe, and the blue line is wool income per ewe. So these take account of the numbers of ewes, obviously, because it's per ewe. But you can see that the trend for meat income has been pretty encouraging. It's running at about 2.7% per year real. So we've taken inflation out of the picture. And that's come about through basically productivity improvements, fertility and growth rate in the lamb. So you're turning off somewhat heavier carcasses, and the lambs turned off per ewe has increased. And that's a pretty nice story. It's overall positive. There's been some flat lining, but it does say something that's quite important to feel and recognise, is that you as an industry have made quite significant productivity improvements, and you've done it through this sort of exercise, through applying good breeding methods, learning how to do that, etc. So you've got capability to tackle challenges and make improvements. It's not like we're talking about, oh, we're going to have to bring something in that's completely foreign, completely new, difficult, etc., and learn how to do it. You've already got some capability in the team, so to speak. We provided, the outcome of the review was a bunch of recommendations to beef and lamb. I'm not going to go into the detail of each of these dot points, but I'll just quickly summarise each one. They're not in a particular order, except they are in an order on the page, and that's how I'm going to follow it, but they're not in that order for some special reason. But we strongly feel that it's a really good idea for an industry to have a vision of where it wants to be, what it wants to be doing 5, 10, 15 years out. And that might sound a bit like kind of hand-waving stuff. See that? Hand-eye coordination, that was. Hand-waving stuff, industry vision sort of thing, but it's actually something that people can start to say, well, okay, yeah, we could do that, and how does that affect me? What would it mean for my business? What would I need to do differently? And also, by coming together and revisiting the industry vision and talking about it, you start to learn and share what is working and what is not working. And it is much more likely that you'll fix the things that need to be fixed and do more of the good things simply by having a shared vision as an industry. I was extremely fortunate in the kind of early-ish days of my career to be in the Australian lamb industry at a time when when the industry set itself some targets which were seen at the time as completely ridiculous, but they've all been achieved. In fact, they've been smashed out of the park, basically. And people, over a period of time, I think increasingly enjoyed and got something real out of the fact that we knew what the targets were, we were tracking how we were going against it, and it helped people, I suspect, grow their confidence in being in the sheep industry. When I started, it was kind of like going backwards really quite quickly. And it's a really positive and valuable thing to have a vision that's got some targets and that get tracked and shared and communicated. The investment plan is really, really important because, and it's a sort of reflection of having an industry vision. Having a vision, to me, implies, okay, I'm going to make a plan of how, or we are going to make a plan of how we achieve that. And part of that is about how much money we spend, whose money it is, and where we spend it. And that should be a shared investment plan. People should know what's in it. There should be pretty good reasons, understanding of why different activities are in it. You know, Beef and Lamb might have a project to do X in the North Island. People understand why. Okay, it's got that much money going to it. This is how we're going to track it. It's a shared. It's like thinking of the whole business of which you're all part and knowing exactly what you're going to spend and why you're spending it and tracking how you're going against it. And it's going to be particularly important for the genomics, as I hope you'll see in a minute. Trait development and goals means just having a clear focus on, okay, what traits are we going to try and do something about? If they're traits that we don't currently include in our genetic evaluation system, how do we bring them in? How do we bring them in fast? Make sure that we've got the good science behind them. What sort of goals should we set for it? I'll use the example of methane. There are several people in this audience who are well ahead of me in terms of understanding and certainly doing research on it. But methane is an example of a trait that 5-10 years ago a few people sort of thought about. It's pretty well there now as a trait that people should be thinking about and including in their selection decisions. There's a process to get to that point. You've got to do some basic research. You've got to work out what the genetics is, how to fit it into the evaluation system, how to put it into indexes. And that part of the overall plan is really important to think, what traits do we want to be improving seriously 5-10 years out, because now is the time to start investing in the research to make sure that's going to be possible and making sure we've got the people who can do it. Beef and Lamb's got a really good genetic analysis system and the IT infrastructure is very good, but that's going to become a bigger and bigger part of making sure that if you like, the wheels can keep turning as fast as you need to. Whatever the size of the database is today, in 5 years' time it'll be at least double, and then it'll double again in 18 months or something, and David Campbell will be driving around in a BMW or 2 BMWs or something. No, sorry David, I shouldn't do that. But but IT is really, really important, and particularly when we get to genomics, you'll see that point about bringing data from everywhere. That's going to become the core business of the IT group. And communications and human capability are fundamental as well. This is a really nice thing we're doing today. Well, I hope you're enjoying it so far anyway. But it's really important to get together and share what's going on, share what's working, what's not working, and it's really important to have humans involved who really want to have a go and who are open and communicative, and they're really good at their job, and Jason's going to be talking about some of that. But there are very positive signs about that as well. So basically, that's a kind of slightly rambling way of saying this is the recommendations we came up with. Beef and Lamb have obviously got the report, and there's a lot more detail in it about those. But it's basically the idea of saying, this is who we are, this is how much we spend, this is what we spend it on, this is what we're trying to achieve, and this is how we work together to get it. And it's important to have all those things. We tried to set a vision, and apologies for this slide, there's lots of words on it, but we tried to say, this is like an example vision. It should not be that the New Zealand sheep industry goes away and said, oh, Rob Banks and Peter Fennessy said, this is what we should be doing by 2050. You people need to build and own the vision. But the sorts of things that you could expect to have in a vision for the industry would be things like growing real income and profitability by at least 1% a year. That's all measurable. It's all communicable, and it would be a seriously good thing to be doing that. So, and it is quite achievable. So that's one part of a vision. The dramatic reduction in dependence on chemicals. It's I have no idea how far we could go with that, but we should be pushing that as hard as possible, because consumers who are prepared to pay the sort of money that we need them to pay do not want to have doubts about what went into the animal that they're feeding their kids, basically, other than grass or feed. They don't want chemicals that might be going in that might linger in the meat or the milk or the wool or something. So dramatic reduction in chemical interventions. Reduced emissions. I'm not going to talk a lot about methane, but it's quite clear that we can do a lot about it genetically. I think, in a sense, we've got a moral obligation as people who live on this planet today to do something about that. If we want to farm ruminants, we should try to stop them pumping methane out. I can talk more later about methane. I'm involved in the Global Methane Hub in a small way. There's a lot of money going into helping people breed ruminants that won't produce methane. It kind of seems to me like a no-brainer that we get the industry to that point. Having a network of really skilled, positive people, making sheep farming and sheep-associated businesses really attractive to talent, that's an important thing. Beef and lamb is going to be a really critical catalyst or facilitator for that. It's not going to suddenly be, well, I don't think it will anyway, the employer of thousands of skilled, energetic people. I don't think that's what the corporate vision is, but anyway. But helping nurture that environment, encouraging sharing of information, and wherever possible, trying to stimulate opportunities for people to continue coming into the industry who are smart, positive, open, want to get on and solve problems. That's a really important thing. The last part of that vision is that the industry knows exactly what it's doing, how it's performing against all its targets, what's being returned to the community, etc., so that the industry knows what it's doing, and it communicates that to everybody who's got an interest in the New Zealand sheep industry, which is basically the New Zealand population. And so it's not just an industry in which things happen, and every so often there's a story in the rural press about, oh, someone's got a sheep that's twice as big as what they've ever seen before. It's almost like the company balance sheet or score sheet is just a public document that everybody involved in the industry knows about, follows, contributes to, etc. So knowing how you're performing and sharing that information is really important. Just a couple of points about sort of drilling into that a bit. At the animal level, it's really clear that the sort of big challenge for sheep farming on farm sense is to ideally reduce labour costs as much as possible. Sheep just require too much labour compared to other enterprises, and maybe people don't, but I think people tend to think of sheep as, oh yeah, you've got to shear them and you've got to drench them and you've got to do this and that and the other thing. And in the old days, there were lots and lots of people who did all those jobs, and cultures grow up about it, and everybody knows about shearing time or crutching time or whatever it might happen to be. Well, it'd be really good if we didn't have to do any of that, basically. If you could run sheep with zero labour, that's not realistic, but it's like getting the labour down to the bare minimum required to capture the value that they've got in them is going to be really important. And the removal of social licence risks is a big part of this. And Pete makes a really good point that productivity improvement, which you've done a very good job of, kind of keeps you in the game, but it's the social licence things that in a sense in the future are going to let you play the game, basically. So animal welfare issues just need to be got rid of, full stop. Emissions should be got rid of, full stop. Chemical interventions that, raise people's doubts, we should get rid of that sort of stuff so that people out there who are going to pay for sheep products, which is what we all live on here, don't have any reasons not to feel good about buying sheep products. That's in a sense what social licence means. You could extend it to things like, the impact on biodiversity, etc., but it's all these things that have kind of been intangible off to the side for a long time are as important as continuing to improve productivity. And we can do something about basically every one of them with genetics. At an industry level, and I get the sense that this is well and truly ingrained in beef and lamb thinking, it's that genetics is just simply an integral part of how we do stuff. It's not like, over there in some funny buildings on some research farms, there's people called geneticists who every so often come out and talk incomprehensible nonsense to humans. Its genetics is completely fundamental and central to the sheep industry being profitable and successful. And that's, for a geneticist, that's really easy to say, because it's so obvious. But for everybody else, it's quite important to kind of break down the barriers of understanding of what genetics is and how it interacts with nutrition and management and so forth. So that instead of, to some extent in the sciences, these things being seen as kind of competing disciplines or interests, they are just seamlessly integrated. It's a bit like the idea that I don't know whether you call it football or rugby over here, so I'll call it rugby, but it's a bit like the idea that a rugby team could have forwards, or it could have backs. Like could have genetics, or we could have nutrition. It's like, that's really going to work well, isn't it? We're having a rugby team that's only got forwards. Well, maybe some of them do, I don't know, but I'm not that up on rugby, but it's the same concept. You can't just have genetics. You can't just have nutrition, and they should be seen as integrated and completely central to making improvement. The point in the middle on this slide, at the bottom on the slide, touches on a sort of intangible thing that we tried to express, is that the next era of the New Zealand sheep industry is going to require more cross-sector coordination, cross-sector communication, people thinking together about what the problems are, about how to invest, what to invest in, etc. So that cross-sector coordination, people planning together, so people like yourselves, farmers, sheep breeders, and beef and lamb working together to think about what needs to be done and how to do it. And you together working with government, for instance, and with the private sector to think about what are we trying to achieve, who is best placed to do it, how do we coordinate our activities, because this, and I think this is particularly relevant from a genetics perspective, but it does apply to other things. But genetics touches every single thing that happens between conception in the ram breeding farm and someone eating a lovely lamb steak either here or in London or Europe or somewhere. Every single point in the chain, there's a genetic influence. And making sure that we're improving that all the way through requires that the ram breeders are understanding what is needed, let's say at the processor level, so that the processor's doing okay. And the processor knows the ram breeder's taking that into account and start looking for the people who are delivering the right product because they've bred the right lamb. And I don't know whether it sounds obvious to you, it sort of seems a bit obvious saying it, but historically, and not just here in New Zealand, that sort of coordination and across the chain understanding has not been something that people have really tried to make sure was happening. It's like, oh yeah, a few farmers take an interest in what happens in processes. Well, they're a bit weird, you know. But you've got to think about it as a whole industry, the whole chain. Genetics is impacting everything, and it's really important that everybody in the chain understands that and feels part of the process. Okay, I presume I'm going sort of double time, so this will be a bit quicker now. Jason's looking really a bit worried, I think. Oh, okay, good. How can genomics contribute? So, really it comes down to two big opportunities. One is faster genetic progress. I gave you a few examples a bit before. People getting 40, 50%, even doubling the rate of genetic progress of what was being achieved, even in good programs. That's happening in a number of industries worldwide. Anywhere people are doing a good job of implementing genomics, they're getting faster genetic progress, and it's because we can pick the animals with the best genetics more accurately, and we can do it earlier. And we can make more valuable genetic progress by, in particular, starting to do something about the traits which have traditionally been seen as too hard to do anything about. Fertility, not such a good example in New Zealand sheep. Some of the disease traits, things that farmers can't readily measure on farm and that you can measure before the animals are being used for breeding, traditionally there's not been much genetic progress made in them, but genomics kind of unlocks that. So it's really very, very exciting technology. In some ways it's an extension of what we've done before, but it gives a lot more scope for control and precision and speed. But, this is the big but, it only does that if we've got what's called a reference population, or we've got phenotypes or records for the things we're interested in. So, I'm sure you all know this, but anybody who comes selling you a genomic test, it's always a good idea to check, do they actually have the data underpinning their test? Has anybody worked out whether it actually works? It's extremely easy to read DNA and package up some sort of result to say, you know, X, Y, Z. You know, I had my DNA read years ago, and I can't remember any specific thing it said about it, but it's kind of like, oh, you know, you're superior intelligence, that's the sort of thing that appealed to me. You've got the genetics for superior intelligence, and it's like, oh yeah, and how did you know that? Oh, because we had 4 people in some little population in America who were related to the lab that developed the test, and one of them had a PhD, and you've got one of the same genes as them. Whoa, how good is that? Oh, by the way, that'll be $100. You know, it's like genomics is really, really great, as long as it's got great data behind it. And I'm going to spend a few minutes now just talking about why that is so important for the sheep industry. Genomic prediction is a very simple thing, but it's got one big feature that you've got to understand. We start off by measuring lots of sheep and they're reading their DNA, and that's called the reference population. And that little graphic there of those sheep standing neatly in line, moving to the right, that's actually, you could use that as a sort of little ad for virtual fencing. You can make the sheep stand in line. Sorry. You've got to have a reference population, and it's got to be a certain size. We can talk about that in a minute. But that sets up the basis of being able to predict things. Once you've got that, you can then go into the same population, but of animals that do not have a record. You can read their DNA and work out how good or bad they are genetically. So that's what that little group of white sheep is about. They're animals that do not have their own records, but we're reading their DNA, and we can predict their genetic merit for whatever traits we've measured in the reference population. We can predict on the group of animals down to the bottom right there. And you cannot stress too much, or I cannot stress because I'm the one talking at the moment, but one cannot stress too much that it's completely dependent on what you've measured in the reference population. If you haven't measured something in the reference population, you basically can't predict it in those animals you just read the DNA of. There's a kind of there's a relationship such that the more animals you've got measured in the reference population, the more accurately you can predict genetic merit. It's kind of diminishing returns, but nevertheless, that's the basic principle. But it's so fundamental. If you want to be able to do that, to work out the genetic merit of the animals that you have not recorded, you have to have measured that trait in the reference population. So there's a kind of choice straight away. Do we just genotype some animals that happen to have some measurements for a few things and say, whoopee-doo, we've got some genomic prediction going, or do you consciously think, what do we want to be able to know about the animals? Therefore, what do we want to get some reference data for? 5 minutes, my God. Thank you. So the fundamental challenge is to get the right amount of quality data for the traits that matter. And that means we've got an investment question, basically, because we invest in phenotyping in the reference population, and then we harvest the value in the young animals. So investment means we've got to think about what we're investing in and how much. Done that before. There we go. Now, I just want to spend just a little minute on who pays and who benefits here. I've just said that. Hang on. There's a kind of pretty simple investment logic to this, I think, and it's the bottom part of this slide, so I'll just read through that a little bit for a moment. We know the relationship between the accuracy of our genomic prediction and how much data we've got for a trait. So we can work back from that and say, okay, we want to improve trait X, we want to be able to improve trait X, whatever that might be. What's our current accuracy for it? How much do we want to improve that accuracy by? That tells us how much we need to invest. So we can actually work back from where we want to get to work out what we need to invest and in what. And in a sense, I think that's such a simple principle, it's so obvious, I'm sort of slightly embarrassing talking about it. But it's whatever do we want to get to, what's our current accuracy, what would be the value of more accuracy, how much will it cost to get it? And that leads to the question of, well, where are we going to get the data from, the phenotypes? Currently, most of the data comes from stud breeders, and it tends to be for traits that are relatively easy to measure. I think in the future we're going to end up in a situation where data comes from a range of sources, including just breeders. and we can understand what their cost of recording are and how much accuracy they're genotyping, and then we're going to have other people who will just genotype, and they might be, just read the DNA, they might be ram breeders, they might be commercial producers, they might be processors, they might be even retailers. But I've tried to work out a way to share the costs of that phenotyping so that everybody is getting the same return on investment. And the return on investment is accuracy divided by the cost of getting it. And this is possibly the greatest graphics you'll ever see in your life, I would say. Over here on the left, these green buckets represent people who are measuring things on sheep. So there might be the growth rate or the fertility or the wool card or disease or something. And there are the green buckets, they're the buckets of phenotypes, and they differ in their size, which reflects differences in the accuracy of the recording and how much it's costing. So we've got kind of high, expensive recording, moderate and low. All that data goes into that wishing well, that's the reference population, the source of all goodies. And over on the right, we've got people who are just going to read the DNA on their sheep or on the sheep products and get some information. And all that we're really trying to do is to share the costs of those green buckets across the whole system. And the way to do that is we've got to work out how much money do we need to collect from genotype only, which is the blue bucket. How much money do we need to collect from those people to spread back across the green buckets so that everybody is getting the same return on investment? The little red arrow is how much we have to collect per genotype to do that. And I've done some sums which I'll be expanding on in the workshop session later, sort of realistic scenarios for New Zealand. I won't go into too much detail except to point out what the red arrow looks like. This is a situation where we've got a reference of a bit over 100,000 animals measured for different things, and we've got 2.5 million animals being genotyped. So they could be other stud animals or they could be commercial animals. But in that situation, you can work out what the costs are, and we need to collect 83 cents per genotype to earn enough money to share around so that everybody's getting the same return on investment. So the nice thing about that is 83 cents isn't very much money. So it's kind of, we're not talking about something that's going to break everybody's finances. If we double the size of the genomic population, or the genotyping population, we reduce that by another half. Now, I'll be going into this a bit more in the sort of later on sessions, but it ends up being that the people who are doing the phenotyping are basically getting a bit under half their costs covered by a rebate from this system. So that's a very quick overview of a way of sharing the costs of the reference population and doing it completely equitably. And so just to finish up, just to summarise what I've said, stripping the costs out of sheep production is really important. Genomics is a big opportunity. Breeders are really, really important to it, partly because they do phenotyping, but also because they actually generate the genetic gain. There's lots of benefits of getting more and more people just genotyping. We semi-jokingly said we should be genotyping every sheep animal born in New Zealand. That would be a really great outcome to get to. We'll have to get the price down, but volume brings the price down. And the last thing is you've got to think about it as a total investment story. What are we trying to achieve? Where are we placed now? How much can we improve that by spending more on the reference, and how do we share those costs around as much as possible? Thank you.
Thank you, Rob. Thank you, Rob. That was great. We've got a few questions that have come up on Slido. So the first one is, why chase methane? Can you tell me the difference it will make to the overall temperature increase? If it is only a feel-good trait, why chase it?
Okay. Firstly, I don't think it is a feel-good trait. methane in the atmosphere contributes to global warming, which is not a good thing. So it's worth thinking seriously about. Secondly, it's quite doable. It's pretty clear that we can achieve at least 1% reduction per animal per year without much trade-off in other traits. I think it's quite reasonable to think of it as currently it's energy that the animal took in, or there is energy that the animal took in, some of which it didn't use, and that came out the other side as methane. Well, if we could use that energy for productive purposes, that would be better. If I say, because lots and lots of people would really like ruminants to produce less methane and therefore they'd be more favourably disposed to the livestock industry, that's kind of saying the same things over again, but it's also true. So,
Can I just add to that?
go for it.
And you mentioned a number of times, as I did, social licence to operate. So certainly Kate Ackland, our chair, and Rona Hume, our head of policy, for the last 5 years has been working with the previous government and this government on reducing the methane targets. We've gone from 24 to 48 as a range down to 14 to 24. So a substantive reduction in the targets that were set under the previous administration. And I think it's back to that social licence to operate within New Zealand, trying to keep it out of the political sphere, which I think we've done this time. So I don't expect it to be an issue in this election. The other aspect is, as many of you will know, under FTAs with both Europe and the UK, a focus around greenhouse gas is also important. So that's the consumer and the customer putting that on us as well. But I think now we've got a livable balance.
Yep. Can I just add one thing to that, Alan? Thank you. The other reason is, let's assume for the moment that we don't want climate change to get worse, regardless of what's causing it. Reducing methane in the atmosphere will be a good thing. Ruminants contribute to it. There'll ultimately be two ways of doing something about that. One will be genetics, and the other will be feed them something that means they produce less methane. There's a couple of those sorts of things available now, at least in different parts of the world. The downside of relying on feeding them something is we will be paying the cost of that forever. And forever does not mean until the next election or till I'm retired or something like that. It means forever. And this is perhaps not in the best taste, but I think it's a pretty graphic thing. Relying on additives like 3-NOP or the Asparagopsis or something like that to suppress methane production is like being a heroin addict, because you've got to get it and you've got to pay for it, and you'll pay for it forever. And
on that happy,
that's not good.
On that happy drug addicted note, I am mindful of time, but there's a couple here we just need to get through. Some of these I might have to just put into the parking lot, so I apologise for that, but we will come back to them. Quickly, what is the current percentage of New Zealand breeders doing whole flock genomics, and is there a push to increase this?
Doing whole flock genomics is not a large percentage, but I can tell you that we did do an analysis a little while ago. The people who are doing it are doing double the rate of gain of New Zealand maternal worth than the rest of us on the average. What I can tell you is right now into the analysis we have about 80,000 genomic DNA samples per year going in there. And I think it's 195,000 animals genotype per year. But so the difference between those two numbers is parentage.
See that? I didn't trip over. Second question,
if there's a reference group.
Now the first question. Sorry. How accurate is the genomic prediction if I haven't measured it in my flock? it'll be likely to be a little bit less than whatever the accuracy is in the reference population itself. Depends on how closely related you are to the reference. That's part of the challenge about designing the reference so it's maximally accurate for the different breeds and groups of sheep. So, yep. If there is a reference group, then why can't imported stock be DNA tested? They can be if that sort of stock is represented in the reference population. If they're not, then the prediction it won't be reliable. So that again is a kind of reference program design question, which comes back to beef and lamb and you as a community. Design of the reference is a whole of industry kind of question. Is there a way of getting scale on genomics by working with the Aussies? What a quaint question. Of course there's value in doing that, and it's a win-win. But it's not going to be Australian data is not going to be useful for all the sheep in New Zealand because you've got some different breeds from us in Australia and vice versa. But anything you can do to increase the size of the reference population of animals that are relevant to your population is a no-brainer. The question about the dairy industry, that's a really interesting one. Where's it gone? Oh, down the bottom, sorry. I think that question's slightly misframed. My understanding is that what was done by LIC and CRV was they measured methane production on some growing bulls, and the bulls were on feed, I think. So they measured the methane in those animals. They bred some daughters from those, the tops, the highs and the lows of those bulls, high methane, low methane. They measured the methane production in those daughters while they were growing, and they've now got to the point where they're starting to measure the methane of those same daughters as in their lactations. They found genetic differences in the bulls, the young bulls. They found genetic differences in the growing heifers that kind of reflect their fathers. What they haven't got so far is a very strong relationship, in fact it's very weak at the moment, between the growing animals and the lactating animals. And that is partly likely to be simply the numbers of animals they've been recording. And I think it's also plausible that the relationship between what you can measure in a growing bull on feed and a lactating cow at pasture it's unlikely to be, it's like 100% correlation. People are not sure about where it might sit, but that's the story there.
Rob, we're going to have to call it.